Okay, hello everybody. Welcome to the measurement module, and what that material starts to get into is some of the technical tools now. In the previous modules, we've covered kind of the philosophy, problem-solving approaches, management strategies, and now we're ready to kind of get into some of the nitty-gritty tools that we use to kind of start affecting a real lean transformation on a model value line. So when we talk about technical tools, just like with management, there's kind of two questions here. The first one is, when do you need to use these tools? And then obviously the second one then is, what are these tools actually? And those two questions correlate to the next two modules actually. The tools to measure, which is the one we're on right now, and then the tools to improve, which is the next module. And those each two things, just like in the management, we've got some symmetry here, correlate with the understanding and skills. And when we can put those two things together, that's really when we're able to affect a true lean transformation. So what we're going to be discussing in this module again is the tools to measure, and there's really three kind of topics that we're going to be covering with that. Key point indicators, yield and defect rates, and then the last one, material and information flow. MyFlow is the acronym for it. And we're going to go ahead and get started in this section with a little discussion on key point indicators. So we'll just start right off the bat with what are key point indicators, given a little bit of a definition. And really what they are is they're tools that we use to understand performance over time. It's a way that we can track our baseline performance of any given process or any activity that we're looking to start measuring to make an improvement. Remember, that's one of the key things we've got to do going back to the management module in terms of planning improvements, is understanding our current condition. KPIs are a great tool for helping us to kind of quantify that and to see that. And then the last one there is to track progress. So we use these as a tool to see where we're going, how our performance is changing again over time, and to track our progress to see if we're getting closer to our targets. And really what it is it's kind of a visual way to go about that. Something that's easier to see, easier to understand the information, easier to see status at a glance than looking at a big spreadsheet with a bunch of numbers. We want to make it visual so that we can just quick at a glance see our status ahead or behind, how are we doing on making progress towards our goals. And then the key point out of this is that really for every target that we set, we've got to have some method to actually track our progress towards it. And that's what we use our KPIs for, to be able to see how we're doing and if we're making progress towards meeting our goals. So just real quick, we'll kind of run through the couple steps, kind of at a high level, of how to go about creating just a KPI in general, a generic KPI. There's really 5 steps. The first one we want to do is we want to actually define the performance goal. What are we trying to do? Then we want to look at a measurable. Okay, how are we going to understand? What are we going to measure to let us know if we're getting better or getting worse? Then we want to kind of come up with a method for how we're going to collect those measurements. Something standard, something repeatable. How are we going to make sure we're getting good data? Then we actually want to follow through and collect the data consistently. If there's big gaps in our history or our record, it's not going to be very informative if we don't know what's happening. And then the last step is, once we have that data, we can put it all together into a chart visually, so it's easy to see, easy to share, easy to digest, and easy to use as a tool, which is the most important thing. So just as an example, kind of taking a look at these steps. So for step 1, defining a goal, in theory, just hypothetically, that could be to reduce production lead time, right? That's a common, something everybody is interested in doing. So a measurable for that could be the number of calendar days from the start of production to completion, right? We have our goal, and then we have how we're going to measure that status, that how we're going to determine how close we are or what our performance looks like as it relates to that goal. Then collecting or creating a method to collect those measurements. Okay, well, hypothetically, we could use the time clock entries to track the start and finish dates per unit. Whatever it could be, as long as it's something that's repeatable that we can follow through with. Then we want to collect that data consistently. So in this case, we're going to record the lead time for each unit produced every week and just collect that information. And then the last step is we want to be able to put it into a chart so we can see it visually, to see where the trends are going, see where our targets are, and see how we're doing, see if any problems occur. So just quick, kind of based off that thinking, these are just a couple sample KPI charts that we threw together, just to represent kind of what these could look like. And really for each area, certainly for every improvement project, but just as a general tool, it's good to kind of put together an information dashboard so you can see status at a glance. for individual groups or areas or product lines or whatever, to kind of keep track of all the important things that we're trying to measure and stay on top of. So in this case, for this department, they were looking at the amount of inventory they were buying, how much stock they had, how many hours they were clocking per month versus the number of actual orders they were putting out, how much scrap, the rework that they're sending out, all the relevant information to be able to see the performance of that area, because that's really what we're trying to get at with this. So then once we've created them, now we need to kind of have a smart way to actually analyze it, to look at that data and be able to make smart decisions based off what it's telling us. And to do that, there's kind of a couple discussion topics that we're going to hit on with this. Kind of the basic measurements, looking at different types of variance. Then these two ideas of confidence intervals and capability indices are pretty important. We're not really going to get into the nitty-gritty of the math because I think it's more important at this point to just understand why it's useful. The math is available, anywhere you can look it up and find it quickly. So we're just going to more focus on the actual applications. And then the last one is statistical stability, which is also kind of an important way to look at our KPIs to understand when problems are occurring. And really, when we put all this together, it kind of forms the backbone of the statistical process monitoring concept. A way to use data to tell us, what's happening in real time. So for basic measurements, really the goal is we collect all this raw data. Now, how do we start actually making sense out of this? You've got kind of the 3 M's, and this is something that almost everybody is very familiar with. Mean, which is just an average of all your numbers. The median, which is halfway between the maximum and the minimum. And then the last one is the mode, which is the number that occurs the most out of any given sample. But what we really want to look at is what about that variation? Because those 3 numbers don't necessarily tell you if all of your data is clumped real close together, which is what we want, or maybe it's spread out really large, but the average is still good, right? So we need to understand and be able to see that variation. So there's 2 good ways for looking at that. The first one is range, and that's kind of the gap between the maximum and the minimum. And then the second one is this idea of a standard deviation, which is a statistical term. And what that really means is just how tight that spread is. Is the data clustered close together, or is it spread out really far? And that variation is something that we need to focus on, because that's going to really give us some insight into how effective our process actually is at turning out consistently good results. So there's 2 types of variation, and kind of digging into that a little bit further. There's short term, which is kind of the natural random stuff that just happens day to day, because no process is going to be 100% repeatable. While that may be our ideal goal, and the reality is even machines have small tolerance issues and things like that. So every process has some sort of small scale variation, and that's okay. We want to understand what that is. And we represent that with sigma short term. And sigma is just the symbol, Greek letter, for standard deviation. So you've got your short term standard deviation, which is that natural random variation. And then you have your long term standard deviation, this sigma long term. And what that is that something we look at for when there's been an actual shift in our data. Something has happened there. Maybe we added a person, or changed new equipment, or made a change to the process. But something external happened there that has now caused the shift in the variation of our results, either for the better or for the worse. But that's something that's happened, and we need to understand that and be able to see that. So there's kind of the distinction there between the normal stuff that's okay and the external stuff that's not okay that we need to be able to see. I kind of put this in here also in terms of being able to visualize data, and this is kind of a good example. So say we're tracking maybe 4 or 5 different production lines, and so we put it together just as a line chart. Now if we look at that, can we actually see the variation in each one of those different lines very well looking at it in this format? And my guess would be no. It's difficult to see what's really going on there. You don't really understand what we're looking at. We can't really tell what's better, what's worse. So in these cases, it's important to kind of change the format sometimes of our KPIs. Line charts, pie charts, bar charts, in this case a box plot, whatever it may be, so that it's easy to kind of see quickly what we're trying to get out of this information. So in this case, now once we've converted it to a box plot, now we can see between those 4 things which one has a wider spread, a tighter spread, better average, worse average. it jumps off the page a little bit better, and so it's just a better tool to use. And so that's a good thing to keep in mind when you're putting these KPIs together and you start analyzing the data, is it even organized and laid out in a way that makes it easy to see what we're trying to find. So moving on from that, what we're going to kind of talk about next is this idea of confidence intervals, and really that's represented with the question of how sure are we. So if I were to ask you, if we had two separate production lines and each one of them made, in this example, 300 6-inch parts per day, and we're trying to find out, is one of them better than the other, and we can collect some data on it. So say we take a random sample of 5 parts off the end of line 1, and the average length is 6.1 inches. We take the same 5-part sample off the line 2, and now it's 6.4 inches. So which one is better? Well, if our target was, say, 6 inches on the nose, you might come back, or anyone might come back and say, well, line 1 is better because it has a better average. But how sure are we? Because if we went back 2 hours later and took another sample, another random sample of 5 parts, we very likely could get this data. So now line 1, for those 5, the average was worse than for line 2. So why are they different? Which one is actually better? How do we know what's happening here? And the idea out of that is to use this thing called a confidence interval. And there's two different ways to go about it. There's a confidence of averages, which is the first thing that we'll take a look at. So if we have our 3 processes right there, and we say, all right, those are the averages for what we collected. How do we know which one is actually better? Well, just looking at the average, we might go, well, process 3 is better. It has a better average. Well, because every random sample has a slightly different average, and that's just kind of the statistics of it and the way it goes with random sampling. If you're making 1,000 parts and every hour you're only checking 2, you're not possibly going to be able to check all of them, and every 2 that you check are going to be a little bit different. That's just the way it goes. So when we just look at raw averages like this, it doesn't give us a very complete picture of what's actually happening. And so what we want to do is we want to calculate these things called confidence intervals. Again, we're not going to get into the math because that's a little bit more. We want to focus on the high level of why this is important. And essentially your confidence intervals are like your error bars, your margin of error for your averages. So when we calculate our confidence intervals here, where in the case where they don't overlap, now you know that there's a real tangible difference between those two. So because 2 and 3 don't overlap, 3 is actually, in reality, a better process than 2. But when you look at 1 and 2, whereas when we just looked at the average, it looked like 1 was better, once we calculate the confidence interval, we find that the variation for 1 is so much worse that statistically there's not really a difference between the two of them. What we were finding with our average was just our own error in the way we were randomly sampling. So that's why this is important, because we could have very well been sitting in a meeting and made a decision that we were going to switch process line 2 to do everything the way line 1 does because we think it was running better. Well, what we did then is we just spent a whole bunch of money and time not really doing anything better. We should have made everything be the way line 3 was, right? That's why we want to use this type, to be smart about how we use the data we're collecting. So then the second way is confidence of percentages. So the first one relates to averages. And again, percentages looks at things, in this example, of like a defect rate is a percentage. So now, same thing. We calculate a defect rate for the day. A defect rate for the day. Is 2 actually better? Well, how do we know? Again, confidence intervals. This time we'll calculate them for averages, and that's actually going to show the real difference. So really, kind of just as a review, when we're looking at how are confidence intervals helpful, the main takeaway here is that when we take the time to calculate these intervals based off the data we're collecting, it shows us really and truly what's better, option A or option B. We're not guessing. We're not making important decisions based off an incomplete data set or incomplete understanding of the numbers we're looking at. It's a way to know for sure, and as much as possible, what the right decision is. And that's the real value of taking the time to do this and to understand what's happening in our KPIs at a little bit deeper level. That's why we want to do this. So the second thing we're going to talk about is this idea of process capability. And the thinking behind that is when we look at capability, what we're trying to understand is, can we meet our specifications? The way our process is currently set up, the way we're currently running, the results we're currently getting, can we actually meet our specifications reliably and consistently? And so there's these numbers that we can come up with called capability indices. And again, just like the competence intervals, not going to get into the math here, but that's easy to find. But there's one set that are called short and long-term capability indices, and what they tell us, the numbers that we get, is how well that variation, that spread, fits within our specifications. So, for instance, say, going back to the previous example, those parts were supposed to be 6-inch on the nose. Well, what if we came back and said, well, they could be 5.8 inches to 6.2 inches, right? There's always a range because nothing is perfect. So the short and long-term indices, the CP and PP, tell us how well our results, based off, the data we're collecting, they predict for us how well our process would fit within that range. Can we say consistently, yep, we can make those parts? Or those numbers are going to tell us, we're going to struggle to make those within that range. We're going to have 10% of them are liable to be bad. We'll have to throw them away, right? That's the value of those. Then we've also got adjusted versions of these indices, right? Short-term variation and long-term variation. What the long-term indices tell us is the variation shifted from the middle of our specification range, right? So is that clump, that range of our results, is it centered right in the sweet spot, in this case right on 6 inches, or is it shifted so that all of them are a little bit shorter than they should be, right? That's what those tell us. And so what they really mean then is we can compare them to each other to give us an idea of how our process is running and how we need to go about trying to improve it if some of these numbers let us know that there's a problem here, right? Analyzing this data to really find out what it's telling us. And so using this quick chart, for instance, if CP and CPK and PP and PPK, if those two sets are equal, that lets us know that the process is centered where we want, but the variation is too great. So it's on average, we're right about where we want to be, but we've got too many of our parts. The distribution is too wide. We're going to make a lot of bad parts. So the improvement plan there is, well, let's tighten up that variation. Let's find why one of them is 5.2 inches and one is 6.8 inches instead of being within that tight range, and let's find a way to tighten that up, right? Let's improve that sigma score, tighten that variation. So the second one, if CP and PP and CPK and PPK are equal, then what that tells us is that the process is offset, right? Everything is too short or everything is too long. We can get this right from just the data we're collecting without having to take a sample of measuring every single thing. This lets us take the samples that we are getting and make predictions about what is really happening. That's what this data is telling us. So in this case, we could just focus on recentering that performance, right? Why is everything too short? Well, let's find a way to recenter that. That's where we need to focus. We don't need to waste our time trying to get them all closer together. We need to get them all closer to the right length to begin with. And then the last one there, if CP is equal to PPK, that lets us know that the process is operating at the current best capability, right? The way it's structured right now, the results we're going to get is as good as we're going to get. If we've got to get better than that, then we really need to make some real changes and kind of look at leveling up how we even go about this process to begin with, right? Major overhaul in this case. So when we look at why the capability indices are helpful, it's kind of the same thinking as why confidence intervals are important. It's why we take the time to come up with these numbers, to look at it, to kind of dig through this information that we're already paying the money and already taking the time to collect. Capability indices help us because they give us an idea on where to direct our improvement efforts, right? Do we need to just completely blow up the process and start over to make it better? Do we just need to shift it a little bit? Do we need to focus on tightening up the variation? Where are our efforts, our time, and our money going to be best served to get the results that we want? That's the value of calculating this. And then the last thing we're going to hit on is this idea of statistical stability. And what that really means is, how do we monitor our KPIs to find an abnormality? Is that spike we see in the chart, is that really a problem? Or is that something that's just going to happen from time to time with variation, given the way our process runs normally? So in this case, looking at that spike on the chart, is that an actual problem? Is it not? Should we go look at that? Should we follow up on it? Or is that okay and we don't need to worry about that for right now? So again, how can we tell? Well, we use this idea of control charts. And again, there's some more math here, and we're not really going to get into the math. There's actually a couple different types of control charts depending on the situation, the data, and things like that. But we're going to kind of shy away from getting too far into the details on that stuff and more focus at the higher level on how it's valuable and why it's worth the time to investigate and put some effort into setting those things up. So the key point takeaway out of here is that a control chart actually shows the real abnormalities, right? The ones that are statistically relevant, that are true. And when a control chart shows an abnormality, that means we do need to go look at it. Something external happened. This is a real problem that needs to be addressed. So we'll use a sample one, and this is an individuals and moving range chart, which is one type of control charts, which is useful for data that's in kind of a smaller lot size. But what it'll do is the individuals chart, it shows our variation over time. And then the moving range chart shows our change in variation over time. And the reason we want to look at both of them is for the regular individuals chart, just showing variation, we want to see, is production taken off? Did we have a real steep drop off? What's going on? Then the change in variation one shows us day to day. Well, are we seesawing? 5 here, 20 here, 10 here, 5 here. What's going on day to day? Is that change swinging dramatically? So it's important to kind of look at it from both sides to see, are we changing unpredictably, or is our overall total number, unstable and unpredictable? But what we do with these is we calculate these things called control limits, and you can see them here on the chart in the green lines. The arrows on the chart show them in the index. But what those are is they're calculated. There's a formula for it again that uses our regular data to come up with these control limits, and they let us know that if anything crosses that control limit, either above or below, that's real. Something happened here that we need to go investigate. As long as, in this case, the blue line stays within the green lines, everything's okay. And that's normal process variation. It's when it crosses one of those green lines, when it crosses one of those control limits, that's a red flag to us that something's happened, we need to go investigate. So real quick before we kind of review the concepts, why those control charts are important is the same thing as the capability indices and confidence intervals. It's using the information we're collecting to let us make smart decisions about how we spend our resources. For instance, on the control charts, if we had seen a spike, but we didn't know if that was really something to look into, we could have sent our management team on a wild goose chase for 3 weeks chasing down a problem that wasn't really real, when we were having real problems somewhere else that we should have been focusing our time on, right? It's a way to let our data tell us where the real problems are. So kind of in summary, with the concepts that we talked about, with KPIs, we want to look at what data we want to track. Then we want to make sure we're consistently collecting that. That's key. Gaps in the data are a real killer. Then we want to create our charts, remembering to kind of think critically about how we represent it visually so it's easy to see. We don't want it to be kind of a cluttered mess. We want the comparisons we want to be able to draw to pop out at us. So quick status at a glance, we can see what's going on. Then we want to use kind of some of these concepts we talked about, confidence intervals, control charts, things like that, to analyze that data, to really understand what's happening so that we can make smart decisions and we can monitor our data for the true abnormalities. And kind of the key point takeaway out of this entire section is that KPIs, this idea of a KPI, this idea of collecting data on our progress, tracking it, seeing it visually, it's really an essential tool for being able to plan and to implement our Kaizen activities, our improvements, which is the whole goal of what we're trying to do. These enable us to make smart decisions about where to improve, how to improve, when to improve, and to see if we're being effective and successful at it. That's the real business value. That's the need that these KPIs fill, and that's why it's absolutely critical that we put in the legwork up front to set ourselves up with this information to use down the road. And as always, any questions you got, just direct them through the website, and we'll see everyone for the next section. Thank you.